project delivery. So uh, we'll start with the basically presentations by our esteemed speakers, and then it will be followed by a question and answer session. So I would request everyone to please write down their questions in Q&A box so that I can pick up and put it in front of our speakers. So first of all, I would like to invite Chakre sir. So Mr. Jain is the chairman of board at Capricorn Technologies Private Limited, and he did architecture from IIT Kharagpur and started his AutoCAD training and consultancy just after graduation. He was initially focused on application of CAD in architectural design, but soon moved into partnership with Autodesk and expanded into software solutions for entire building and infrastructure industry in the name of CAD Studio. So over to you, Chakre sir.
Thank you, Farhad. So first of all, welcome to everyone and to our this webinar where we have a very well-known speakers like Anand Sharma, Hitesh, and Sabir will be presenting their views. So I'll not like to take much time. I'll just briefly introduce about Capricorn because we also have recently gone through some changes, and then we'll hand over to them. So as an organization, we have been evolving. So I started initially way back almost 36 years back, my organization by the name Cat Studio. And then as a part of our strategy to keep on growing our organization, then in 2013, four of us Indian partners, we merged and formed this company, what we are using the name today as Capricorn. And we were fortunate enough then to get some investments from a German group, RIB, into our organization in 2019. And then this company, RIB itself, got taken over by Schneider. And as a benefit of that to us as Capricorn was, we got together with three other partners like us, Autodesk partner across Australia, US, and UK, and formed this new company by the name WinZero. And as it would have it, on from 1st June, just 2 months back, we also again went through another transformation, and so the life is like that. And if you keep on doing changing yourself, today you get outdated very fast. But the fortunate enough thing has been now we have now become a part of a global group, Kans, with presence in 18 countries across the world and serving customers like yourself with Autodesk technology with very specific focus on architecture and construction industry. So today, as an organization, we have reorganized ourselves into three separate geographical location: Americas, EMEA, and APAC. So this is how we have internally now reorganized our organization to serve you better. And if we can, Farhad, go to the next slide. So as an organization, of course, we know today digitization is something very critical for this entire construction industry. And I'm sure our speakers would be talking about that in more detail. And that's where what our role and responsibility is to help you use digitization and then you leverage it for improving your design, serving your customers better. And that's what our primary role today is. And without getting into too much of detail, just one more slide we have. So today we are serving customers like yourself from 50 different locations across the world in 18 countries with more than 40,000 customers present across the world. So this is our basically on the right side, if you see, is our how we are organized. So the Monier, a French group, is the owner of all this organization, and under WinZero we are present. So without talking up, so basically we are today becoming, we can claim ourselves to to be one of the largest partner of Autodesk across the world, or in that way there are very few such organizations serving the construction industry. So that's what we pride ourselves into. Okay, now coming back to the topic, before I hand over back to Farhad, I'd like to share some of my experiences in this journey And one of them is like when initially we started using AutoCAD way back in early 90s. One of the skepticism of all the users used to be, oh, computer means, and let me use that word computerize or computerization would at that time mean in AutoCAD means you will have very, very regular buildings. What about doing some irregular buildings? So people were very skeptical that I'll be able to only draw or create very boxy kind of. That was one of the feeling a lot of architect used to convey at that time. And then came the second stage, where a lot of architects started using maybe more of 3D Studio Max and Maya than AutoCAD. And then they went overboard with such difficult design for their architectural expression. That is, some of the countries like China, they had to even kind of restrict people that don't design using these software. And I think now we have gone through the third stage where there is a realization of using this entire piece judiciously. And that's probably what we're going to say, that how can I balance my creativity, what I want to do, my architectural expression with whatever design and the form I want, but still be able to work out engineering behind that, still be able to work out execution behind that, and be able to deliver my project with my expression, but still meet the goals of my owners and the users. So with that, without taking much time, I'll like to hand over back to Farhad.
Um, Thank you, sir. So thank you for giving us the introduction to the topic and how it is very much related to all the design and construction professionals. So first, I would like to invite Mr. Anand Sharma from DFI. So Mr. Anand Sharma is a BR honors graduate from the Indian Institute of Technology, Kharagpur, and a co-founder at Design Forum International. He believes in practicing socially inclusive architecture and has coined the term people first, which became one of the guiding principles of the practice. Over the last 25 years, he has been instrumental in the firm's journey of being a part of nation building across the country. He has worked across diverse project typologies where he leverages his expertise in architecture, engineering, and construction to provide unique and efficient design solutions. So over to you, Anand, sir.
Thank you very much. You put it much better than I would have put it myself. But nevertheless, I would share a project of mine, which is where I think showing is much better than, just talking about it. I hope my screen is visible to everybody.
Yes, sir.
All right. So as architects, I'm no BIM specialist. Let me be upfront and let me be very candid about it. I'm a user of BIM, and I would illustrate the kind of complexity that one can handle using BIM as a platform via a project of ours that we've been fortunate to be a part of. You will pardon a little background noise around me because I had a whole day for site visits scheduled today, and I'm still sitting on a site while I'm doing this webinar. But Chakresh asked me to be a part of this webinar, and Chakresh is one of those people I cannot say no to. Other than being the stalwart in the industry that he is, he's also senior from my college. So of course, that special link is definitely there. So I'm going to talk about the new integrated terminal building for Guwahati Airport in Assam, for which we were designers, architects in association with the ECOM. So I will quickly give you a flavor of the complexity involved in the design of the terminal building. And without showing you the drawings that get extracted from BIM, because you all are very experienced, I would take you through a small walkthrough of of Nevis walkthrough using the platform that we had created. And I would like to say this with some sense of pride, that this is the only airport building being undertaken by Airports Authority of India, which has been designed and is being constructed using BIM as a primary platform for design and drawing till it. So it's a approximately 52-acre site, terminal building catering to almost 8 million passengers per annum. There is a verdant front landscape. There is an extremely complicated roof. There is a lot of intricate design intervention into the terminal building, all of which I would take you briefly through. So there is, in airport parlance, what we call the city side landscape, the terminal building and the air side. And there, of course, is the services and the related paraphernalia, but we will primarily focus ourselves to the terminal building. So the terminal building is a very unique origami inspired terminal roof. You can see the bird's level plan of the terminal roof, and you can see the landscape in front of it. If I was to explain the way the building has been modeled, there is an exploded isometric that you can see. There are 5 levels to the building. So there is the arrival level, there is mezzanine, which is primarily for passenger movement from airports down to arrival and so on. The departure level, and then there is a food court level on top of it, which is the 4th level. And the final level and the most complicated level is the complicated roof structure that you'd see on level 5. And then, of course, the envelope of the roof over there. Sectionally speaking, arrival and departure are the 2 levels that passengers are normally part of, and these are also the 2 most important levels of the airport. It is interspersed with baggage, it is interspersed with F&B and so forth. And then there is a special intervention called the Icarus that I'll come to in a moment. This is a cross section through the other direction. All the passenger amenities shown through it. There is a very, very interesting intervention called an urban forest, indoor forest that we sort of enclosed as part of the user experience on the arrival level. So one clear design thought, or rather a chain of design that we were very, very conscious about weaving the entire design through is origami. It is a craft that all of us have sort of practiced in our childhood. We use that craft to create many things in our building, including what we are calling the Icarus. For the uninitiated, Icarus is the mythological Greek figure, the first person who had dared to fly using wings glued with wax to his body, and he jumped off a cliff. And the aspiration soared high. Unfortunately, the person did not, but at least the aspiration of soaring high was definitely there. To give you a sense of Icarus, it is 180 meters long and can take almost 13 buses, length to length, full length buses. So it's a massive structure, as you can see, supported at just 4 levels. It's an engineering marvel all by itself. It rises 26.5 meters from the ground, and there is it spans primarily over the departure concourse, and you can see the canopy spreading over the departure concourse. It is a complicated steel structure. These are the internal steel detailing for Icarus derived from BIM. Some more detailing. It is a GFRC clad structure built with steel and cladded with GFRC. And the eventual end result of the Icarus is going to be looking like this. Some more visuals of it. The origami roof. This was, so we started off with creating a plain rectangle and trying to bring some corners to it. We tried adding pyramids to the sides to bring stability to the form. And then we ended up having a little more fun, making ridges and valleys from the roof. And eventually the result is what it is. It's complicated, but it is also very, very symmetrical and very, very interesting. Of course, there are skylights because it is a green building to bring natural light into the terminal building. And the lights really bring out a lot of magic and a lot of daylight into the terminal, in addition to bringing a lot of drama of shadows and lights. You can see from the check-in hall. More shots of the check-in hall. The trusses, because of the complicated structure that we had, it was only possible using BIM to actually model the structural supports of this. You can see the complication of too many trusses coming into one diaphragm kind of a truss, like a plenum kind of a truss, and all the loads getting transferred onto it. And because we were modeling it all in BIM, we could actually work out the profile of the cladding that is eventually going to be put on top of these trusses, and determine the exact amount of shapes, the exact amount of curves, and the exact amount of curvature needed, and the length of the sheets also to cover a complicated structure like that. And you can see from just these two images in top and bottom give you an idea of what the trusses are and how the trusses have been treated using visualization and working drawings generation tool like BIM. Some more shots. And then there is the indoor forest that I was telling you about. It essentially is a transition point from the arrival atrium via an indoor forest overall onto the baggage collection. And it is located on the extreme sides of the terminal. It is a pyramid, and therefore to join a pyramid into a complicated roof like that meant a lot of intricacy and meant a lot of three-dimensional thinking. Of course, BIM made it easy for us. Just to give you a sense, this arrival atrium, this indoor forest pyramid is 27 meters high, equivalent to roughly 9 floors. So you can see a massive structure, glass-clad massive structure, and that is the internal impact of that pyramid that the passenger will experience walking through the indoor forest over here. We are actually planting shade-loving indoor plants, and because there is abundance of sunlight coming into this, the experience is very, very surreal. I do not want to bore you taking through the drawings that were extracted out of them. You guys are all stalwarts. You understand. It would be, I think, sufficient to say that all the GFCs that were issued on the contractors were derived and were extracted from the BIM model. Our client, Airport Authority of India, client at that time. The project has now incidentally moved on to Adani, but our client at that time, Airports Authority of India, insisted that GFCs were made out of BIM. So I will hang back there and take you through, walk through that so this is the entire model created, resolved through Nevis systems in our consultation and in coordination with our project partners, AECOM. And it's a 4-minute video. Please bear with me. The intent is to show that all the finishing, the truss treatments, the interiors, the flooring, the wall treatments, even the baggage system that you will see in a moment, the check-in islands, the screens, every part of the facade, the design, the interiors, the systems, everything down to the last things as queue managers, we modeled in BIM. It was possible to do it. It's an extremely complicated design, but it was possible, and we made sure that every single design, even the furniture, you can see the facade, the gates towards the airside for passenger boarding bridges. It was possible, and the versatility of the platform gave us the latitude and gave us the freedom to do it. This is the departure floor, as you can see. There is a crafts village that was envisaged as part of the secure building area for the airport. So this portion is all at the departure level at 0 plus 10 meters. We would quickly run to the food level and then to the arrival level. This is the arrival level. You can see the baggage reclaim devices, the false ceiling, the baggage reclaim hall, the baggage collection hall, the services running on top of it, the structural system, the sprinklers, the upright and downright, the ventilation system, even the false ceiling system is very, very visible. We would also take you through the baggage handling area, and you will see that the versatility of the platform afforded us the chance to be able to do all that. So these are the areas where the baggage is coming from the level above. This is the mezzanine back of the house area. Nobody ever sees this area. This is where the baggage is coming from the check-in islands to a level where all security checks are happening. There are huge luggage conveyor belts. There are CTX machines through which baggage passes. So inline baggage screening system, as they call it in aviation terminology these days, is what happens behind the scenes. Then there are rudimentary sections running through toilets and plumbing shafts and everything. The power of the platform down to being able to detail the unions, being able to down to the detailing the diameters of the pipes, coordination of the shafts, overlaying of various services within the shafts. It was all possible, and we went down to that detail. You can see even each and every bend, each and every union has been captured. All the P-traps, the S-traps, all the plumbing system. Baggage handling system, incidentally, is the most complicated services part of an airport. And if it was possible to model that, everything else was, so even the piles, the structure, this is the structure getting cut sectionally from back towards the rear, and you can see all the components of the building getting very, very clearly reflected in this this animation and this video. And there, so it was conceptualized and then eventually being delivered in BIM. So that's about it. That's about it. That's all I wanted to present, and thank you very much.
It's fantastic, Anand. In 5 minutes, you explained the entire airport design.
Thank you, Sanku. Thank you so much.
Thanks a lot, Anand sir. So it was really nice to see how well we can use Revit and BIM in such huge projects. So thanks a lot for that. Let me just share my screen. So our next speaker is Mr. Shabir Lokhandwala from Slabs Engineering. He's the managing director at Slabs Engineering Private Limited. Mr. Shabir is a graduate from IIT Roorkee in the field of structural engineering. He is well known for his modular designs in precast technology across India and globally. Having worked with renowned companies like Aero, he started his own entrepreneurship journey in 2014, establishing Slabs Engineering Private Limited. Till date, he has designed 30 million plus square feet of projects across India in precast technology. He has changed the way precast is designed and built in India with his decade plus years of experience. His passion and drive for latest technology has enabled him to add value to deliver construction projects with faster pace and quality. So nice to have you, Mr. Shabir. Over to you.
Good afternoon, everyone. Uh, Thank you so much for inviting me to this conference today. And I hope I would be able to add value to this session. Uh, is my screen visible?
Uh, no, not yet, sir.
Just a minute. Now, is it visible now?
Yes, yes.
Okay. So, basically, like we have worked, I would like to present the airport project which we have worked on. And how BIM has helped us to execute this particular project of this scale and magnitude. So primarily, Limac is the main contractor on the project, and we were assisting the precast contractors for precast cladding and GFRC cladding, etc. Right. So the GFRC cladding itself, which we were designing, was about more than 100,000 square meters. So the scale of the cladding for this entire project is quite huge. Roughly to tell you, the entire project is about $10 billion project uh, located in the heart of Kuwait. It's one of the largest ongoing project in Middle East right now. The scale of the size of Kuwait International Airport is roughly 38 square kilometers. That's the entire scale of the project. What I would like to showcase to you is one part as a case study of this entire project and how we resolved it using BIM. So, as I think our previous speakers have told, there's several areas in the airport like welcomers area, baggage reclaim area, and etc. So, in one of the areas, let's say welcomers area, we had a doubly curvature panels. So these were all parametrically modeled, and the meshing and massing was done, and also to make the panels production friendly, erection friendly, and so on. So without BIM in place, this would have not been possible if we would have considered the traditional approach of construction. Along with this, we had to do definitely integration with services like sprinkler, alarm system, and other services, HVAC, etc., and do the clash detection as well using Navisworks software. So all these were enabling using only BIM platform. And I would say that more than 100 agencies plus working across the globe to develop this entire BIM model for the entire airport. Some agencies were working on HVAC, fire alarm, some were working on the glass cladding, some were working on the actual structure. Arup was a principal structural consultant. And so there were multiple agencies working on this project since 2017 till date. And till now also the project model is being uploaded and rigorously done, right? So this is the scale of the project which could also be done in BIM, and this is completely done using BIM. So definitely, like this is how the section looked like, and we had to ensure we maintain the gaps for between the panels to align the services, etc. So there was not even plus or minus 2 margin we had to play with the construction tolerances and the design tolerances, so that the panels could actually fit in the exact locations once they're constructed. Then we definitely did the structural engineering analysis and design based on the spanning, etc. Then we had to do some sequencing, panel numbering, the analysis of the panels. So all the data, the core data was extracted from the BIM model, and so basically for one such area, this is how we arrived at the pattern of the panels and the way we'll hang the panels, how we'll increase the repeatability of the panels, how it'll look like, because this is a main attraction while the it's at the arrivals gate when the people are entering in the airport. It's called as a welcomers area. Right. So this is how the entire summary of that area was done. And then based on our design of panels, the secondary steel structure was also defined to hang these panels. So secondary steel structure was again hanging on the primary structure to cater the loads of this panels in GFRC and precast the way we had designed. So this is another area like the shape in plan, but it's if you see it in section, it's a doubly curvature panel. In plan also it's in a curvature fashion, and in section also it's again in a curvature fashion. So this is a waterfall area near the baggage reclaim area. So here also we have to define the gaps to be followed to allow the services, light fixtures in between, etc. And there was a particular line or the groove which had to be considering the architect's vision. Fosters and partners with the architects, and we had to get the approvals in order to uh, get it finalized the way we are breaking the panels, how it will look like, etc. These are some of the sections obtained from the BIM model. And then definitely, to increase the repeatability of the panels, cross section geometries were finalized. And finally, this area was also sorted out. The sequencing, mark number, etc. were done. Right. So this is entirely like the structural approach for this given area, wherein we were involved in facade engineering and design. Right. Now, I would like to just showcase you the real outputs. So these are some of the 3D views which we have captured using Navisworks. Once we uh, like superimposed our models and did the review how the crews will come, along with the other services and stuff like that. These are some of the views from Navisworks. Just to understand from the bottom, how the panels will look like, how the grooves will look like, etc. So this allowed the architects to understand with clarity how the final desired vision would look like. Okay, fine. Now I would just like to show you some of the output results also, so that you appreciate the integration of BIM on a given project. So once we have generated a 3D model, now there were more than, I would say, 25,000 plus number of panels, and I would say more than 2,000 number of drawings to be extracted. So it's a humongous amount of task. You can see the panel schedule, wherein we have a particular unique ID number to a panel given in the BIM model. Then we generate a particular drawing, and then it is automatically programmed in Revit, which tells the production team to refer this drawing to produce that panel, mentioning its exact length and which fabrication drawing to refer to, which erection drawing to refer to, and some panel area and the zone in which that panel is coming, etc. You know, so this is an entire. You can see the panel schedule, which is entirely derived from Revit. From the BIM model. So this is one such fine example. So I'm just taking you in the backward direction. This is the entire panel schedule obtained from our BIM model in Revit. Then these are some sections, connection details of the GFRC panels and how to maintain the gaps for the services. These are ribs and returns with the chamfers, with the secondary support, with the primary support. Then we had some balustrades, how to treat those local joints, etc. This is completely done, by coordinating with other services and structural models to arrive at the entire BIM model of cladding. There's a full section of the panels with connecting frames, primary, secondary, etc. So these drawings are also extracted from the BIM model. The another typical connection details of other junctions. Then this is a shop drawing. Now every panel we have to produce a drawing so that it goes to the production team and then it is erected. So with detailed connections modeled into the panel with the ribs, returns, cutouts, and the exact panel dimensions. Please note that we cannot deviate more than plus or minus 2 mm in the production level. Okay, so that precise, the panels actually from the Revit model were extracted and the drawings are also created using Revit only. So nothing was done on a 2D platform like AutoCAD. Everything was seamlessly modeled, generated, clash detections done, and the drawings were extracted. Definitely for FEM analysis, etc., and parametric modeling, we have used other programming tools and softwares as well. And so this is finer level details up to the fabrication level drawings, even which we have extracted from Revit. Okay, so this is another complex panel which I'm showing it to you right now. So you can see the connecting bars, threaded bars coming out of the panel, everything modeled into the model and drawings being extracted. Okay, so just a minute. So this 3D views also, make very much clear to the production team how the shape of the panel would look like. Unlike 2D, they will have to visualize how the panel will come in 3D. But then once we give a 3D view in the shop drawing, it's very much easy for them to follow the drawings and then make lesser amount of mistakes. So that's the power of BIM, which we got to utilize for this particular project. Okay, thank you everyone. So I would be happy to take up any questions if you have.
Uh,
Yes, Farhad.
Thanks a lot, Mr. Shabir. That's a wonderful way of wonderful example of how practically BIM is used in a real project, and you kind of created a huge database and use it to control the construction and in a very
Yeah.
organized way. That's really amazing, and it's
So
really
unlike airport projects, like all our projects, we are doing it in BIM mandatorily. All our precast projects, we do it in BIM
mm,
because we use BIM till LOD 500, 600 level. It's not only like we are creating a presentation based model for our precast projects, but we, after doing structural engineering analysis and design, we ourselves as engineers, we create the model, we create erection drawings, construction drawings, fabrication drawings of each and our precast elements. In fact, for our precast pieces, we put the rebar also, and we generate bar bending schedule, everything from the Revit model. So that extensively, we are using for all our projects.
that's really good to hear, and it's kind of a motivation for our attendees also. I could see some questions that they was saying that can we use BIM for complex projects or this, but I think now you have reinforced the idea that BIM definitely it should be used for mega projects, big complex projects. So that's a good example and good motivation for the construction professionals.
Thank
So
you.
thank you, Mr. Shabir. Um, Let me just share my screen. If you can just unshare it, so I'll just
Yeah.
thank you.
Is it done? Is it unshared?
Yes, yes, yes.
Yeah.
Now I
Okay.
think my screen has come up. Okay. So our next speaker is Mr. Hitesh Rathore from A Systems 2. So Mr. Hitesh Rathore is a civil engineer and is associated with A Systems STUP as a BIM manager on various complex projects like water and infrastructure across India and abroad. And he's currently working on large scale projects. He has also worked with companies like Lizard Design Inc. USA and 3D Blueprints India Private Limited, where he spent around a decade working on multifamily, single family, mixed use buildings and commercial buildings, which were to be constructed in the United States and in Europe. So we are really happy to have you, Mr. Hitesh. Over to you. I'll just stop sharing.
Okay, good afternoon all. This is Hitesh here from Assistance 2. Professor, can you hear me?
Yes, yes, yes.
Yes.
If possible, you can put. We cannot see you, but I think your
Okay.
video is not.
I'm going to turn on my video now.
Yeah, yes, yes.
I hope you can
No.
see me now.
Yes, yes.
Yeah. So first of all, thank you. I would like to first thank Jain sir and Naman sir and Farah sir for inviting me in this session, in this knowledgeable BIM session. And I want to introduce my company. I like Assistance 2 Private Limited first. The Assystem Group is a system firm of the Assystem Group, a France-based MNC, which has a strong workforce around 10,000 plus of personals worldwide, and we are growing steadily. The Stu Consultants Private Limited was taken over by the Assystems on July 1st, 2021, and rebranded as a Assystems 2 Private Limited. I am working on projects which are complex in terms of specialty like water and infrastructure across India. Currently, I am attached with the projects like CETP, Common Effluent Treatment Plant, STP, Sewage Treatment Plant, and WTP, Water Treatment Plants. We have also developed a few projects on Civil 32, and now let me move further. And so if you notice that now on almost all large scale projects are being developed on BIM platform, and Autodesk is driving it from the front seat. Also, all Asian Development Bank funded projects need to be 100% on the BIM platform from now on. And many government bodies are making it mandatory to develop large-scale infra projects on BIM platform in India. So, which is, I think, good news for us. Now, let us describe the BIM. So, one of the main advantage of the BIM model is the ability to see the digital representation of the building in their schematic context. The visualization helps us eliminate clashes between the building elements. This can help designers to efficiently plan the available spaces and evaluate the new developments against the proposal. Buildings and infrastructure can be seen and tested, allowing the performance to be modeled and modified if necessary prior to construction, where a complete picture of the neighboring areas and current services can be obtained from the BIM models on the urban spaces with all its surroundings. Please wait. BIM helps us to BIM helps us to provide an open platform for an information rich database. Data correction and sharing can help improve not only buildings and in infrastructure, but also healthcare, security and the environment too. The BIM urban space model will be the powerful tool for coordinating designs services and maintenance program primarily. The transfer of idea through three-dimensional drawing is one of the best descriptive models method that can be used to describe a scene. That is the entry of ideas with a technology to the mind through the use of the eye is better than entering it through the description. Because the recipient in the second case depend on his imagination to what the described scene, which results in a discrepancy in the understanding of what is described in the receipt, in your drawing. Now I'm going to share my screen for the clash coordination and my clash detection rules. Let me share my screen first. Okay, can you see my screen now?
Yes, now we can
Yes.
see.
Okay, so the actually I have developed like in-house classification rules and like tolerances. So for architectural elements and floors and like structure and like a structure elements, slab, columns, like fire protection, which whether it is going to be like wet utility or like dry utility, lighting, drainage, or water supplies, we can develop like legislation rules as per like this table, and we can provide the transparency with the tolerance like this way. Uh, Wait for a second. What is happening? What is the class detection coordination cycle? Like along with the beam meeting, there are the various like action to be taken on daily basis. The actual day and an item will be confirmed, but the following cycle is included in the followed below. Mentioned tasks must be completed before the coordination meeting. So when you have the meeting with the client, you need to have the plus your report for your model needs to be ready. So these are the points that you need to take care of those things. And now we will come to the 3D takeoff model. So when the executing a quantity takeoff from 2D designs, there are a lot of fundamental formulas and methodologies you can deploy. These includes the computing unit counts and like determining the required linear length, surface area, weight, and cubic volume of the materials. The object is to turn two-dimensional design into three-dimensional concepts. This aids in understanding the concept of what the project's real life physical like requirements are from the 2D drawing. Are from a BIM model, on the other hand, provides this info immediately, like because it automatically includes the quantities. This is a significant advantage of adopting BIM over 2D design. Quantity takeoffs are like essential for determining a project's material requirements. However, this finding supports other construction parameters such as cost and time for the 40 for the 40 timeline. Now I will show you few projects we have developed particular for the airports. Okay, so currently we are attached with the currently we are working on the projects named as Jabalpur Airport. Actually, I'm not part of that project, and currently we have like designed that project internally, and we have developed that project on like 100% beam platform, and currently we are at the stage of like LOD 350 level. Post that we are attached, give me 1 second, I need to hide this. Okay, post that we are attached with one of the large project based at Maldives. Actually, we are working as a PMC. The name of this project is the Gan Airport, and then the second airport it is going to be developed on the eastern side of the Maldives, Malay. The name of that airport is Minamadu. We are also working. We are also attached with that project as a PMC. So technically, like designer has to develop our designer has to develop their design as per our like senior persons. Was that we have designed few projects for the, let's say, like Noida. So we have like designed it and was that I will show you one more project called like Hyderabad Greenfield Airport. So the scope of service was like preparation of detailed projects like report, master plan, concept design, and including we have ETC and all other buildings too, like cargo buildings and all those things. Post that we had also developed the projects on BIM platform was the Sindhudur airport at Maharashtra. If you can see this on a slide. So the scope of service was the same as previous: master planning, like detailed design project, passenger terminal, like ATC building, and all those all those other buildings too. Post that, I will present you the Durgapur airport at West Bengal. And post that, there is one air terminal we designed for the Benghazi airport, which is the picture has been shown in this slide. And then the next one is the terminal, passenger terminal building at Sheba Airport. The scope of was the same. We have to develop the preliminary design, development drawing, and then terminal building, and with all the disciplines ASMEPF. This view is from Jabalpur Airport.
Hitesh, I think you're sharing wrong screen because we can only see the Word file right now.
Oh, sorry. One second. Sorry. Okay, now can you see my screen?
Yes.
Okay, sorry. Okay. Okay, fine. Okay, so let me go through it very fast. So this is the Maldives airport, which we are currently developing. The name of this airport is like GAN Airport. This is for the Noida airport that we have developed the preliminary designing with the master planning. This is the Hyderabad-based Greenfield Airport. We had also developed the master plan, concept design, and airport traffic control building, like ATC building. This is the Sindhudur Airport at Maharashtra. We developed it on the BIM platform. The scope of the service was the same. This is the Durgapur Airport at the West Bengal. We developed it on the BIM platform. And this is the Benghazi Airport. We just designed it. And this is the passenger terminal building at the Sheba Airport. So the scope of the project was to develop this airport with all the disciplines. So we have the in-house team for architecture, structure, mechanical, and plumbing, and we have developed this project in-house. And currently we are working for Jabalpur Airport. So this is the visual that our design team has developed, and we are working on it. The scope of the service is going to be same. Vijayawada Airport conceptual. We designed it over here. And this is the Agatti Airport at the Lakshadweep. And these are the few buildings. So we have developed around to support the surround area of the airport. So if you have any kind of aircraft hangar, or if you have any kind of cargo building, if you have to develop it, or if you have any kind of a separate parking building that we have to develop. So we have developed it 100% on the BIM platform. And this is one of the facility that we developed attached with Bengaluru Bengaluru airport. And this is also the Air India import cargo. We developed it on the 100% BIM platform. Yeah, the same aircraft hangar for the Gulf Air. Thank you. Over to you, Bharat, sir.
Yeah,
Hello.
thank you, Hitesh sir. I think you are doing most of the airports in India. I can see a lot of airports, so that's good, and it's good to hear that you are doing that on BIM itself.
Yes.
So thanks a lot, and this further helps our attendees to understand how important BIM and Revit is for the buildings like airports.
Yeah, and also I want to share one one of the project for the water treatment plant project that we are working on. So if you can see my screen, Can you see my screen?
No, I could see only the red screen which earlier you were
Okay,
showing.
1 second. Stop sharing. Okay, over here. Okay, so this is the facility of 20 million liter per day. So I will show you around like how this facility would look like. So this is a parcel room. This is the like chemical house. This is the like clarificator. This is our like grid chamber. This is our chemical house that we have developed, and this is going to be our like chlorination building, and this is going to be the large scale like 20 million liter per day tank, like the capacity of this like master blessing reservoir. And we developed it and like underneath that you can see the pile foundation. So there are lots of piles we have developed, we have like erected on site. And over here, if you can see, this is the pump house we had developed, and these are the few workshops and few like admin buildings over there. Yeah. So currently this model has like reached like LOD 300 at like the 350 level, and we are currently working on it. Okay, thank you.
Thank you, Deji. Wow, that is a really surprising that even water you're working on BIM. So that's a new thing for me also. So thanks a lot. So quickly, that was all our speakers. So, but quickly now I want to, there is one bonus presentation by me only. I just want to break some myths. So just spare with me for 5 more minutes. So I'm going to show you a very small example of modeling complex roofs in Revit. So first of all, starting with the computational design. So what is computational design? It is human intelligence plus computer algorithm. So the myth is that, complex designs cannot be modeled on Revit. So we have seen quite a lot of examples of working drawings and clash detections and all detailing of the models, big infrastructure building models done on Revit. But what about the initial part? So a lot of people come to me, they say, no, it cannot be done on Revit. We'll do it on Rhino. We'll do it on, we'll do it using Grasshopper. But I'm going to show you how you do it with the help of Revit and Dynamo. But I'm going to quickly show you a very small example. So computational design is the application of computational strategies to the design process. And strategy refers to the process of taking design decisions using computer language. So this approach helps user in combining the logic, geometry, and calculation to do a BIM model for providing capacity to generate complex order, forms, and structure. So these are quick 5 examples of dynamic facades. This first one is the Kaifer Technique showroom, and which the facade is controlled with 54 motors. It's a shading device. Second example is the Brisbane Airport, done by UAP. So 250,000 parts in the facade. So this facade is continuously moving. This is Al Bahar Tower. So the facade, changes with the sun movement. So it results in 40% saving carbon emission. And this fifth example is the Galleria Center City. So you can see 2 layers of aluminum profile, angled back layer. So, and this is the ocean kinetic facade. So this is the largest adaptive structure ever built till now. So now these were some examples. So I've taken one live example also. So now you guys need to, so you can write the answer in the Q&A box. So I'm going to ask you one question. So can anyone tell me which airport is this? This is in India. This is the 3D view of one airport coming up, which has a very complex roof. So can anyone tell me?
Navi Mumbai International Airport.
No, it's not Navi Mumbai. So
Then
from
Noida
audience, you
International
guys
Airport.
can, sorry? No,
Noida International Airport.
No. So architect, so Mr. Ritesh is from Noida International Airport only, so he can say, no, it's not Noida. So participants can, attendees can just write in the Q&A box. So I'll show you one more 3D. Look, this is from the side. So I can see a lot of answers. So a few people got it right. So Pratima and Akansha. So they've written Trichy Airport. Yes, so this is Trichy Airport. So this is in Tamil Nadu. So now I'm going to show you how we are going to model this complex roof quickly in Revit. So so this is the Revit screen. So quickly we are going to take the basically the template. So we are going to use the concept of adaptive families. So here this is the user interface. So there are adaptive points in Revit, point elements. So we are going to use that. So I had the plan. So the size of this roof is 270 meter by 144 meter. Okay. So quickly we are going to place the points. So these points are going to control the roof, and the more points we use, the more accurate the roof will become, the more curves it can have. So we are going to pick this point element, and so we are just place this and then quickly copy it. And so we have taken up 3 now. This is the one part, and now we can copy this. So point elements has the dynamic work planes also. So we quickly just will copy this. So obviously, as I mentioned, we can have more points and more accurate roof. So now we have created one shape. Now we can play with the points. So we have joined these points with the spline, and we can play with the points, and we can create a very dynamic roof, which is the kind of a prerequisite in an airport, because the airport building is very unique and it has to be good design. So I'm just, so we can pick up the point. You can see that you can play with the roof. So now on the edges, just a stretch to. So on both side, we have the canopies. So next, I'll just show you how to make those canopies in Revit. So here 2 canopies, front and back, the canopies will come. So this is for the canopies. Quickly, I'll just move faster to the video. One second. Yeah, so we have taken the same points. We are going to have the canopy over on both the sides. So we have just copied the points, and quickly, we have attached, and we will just make this surface. And the front canopy has come up. So quickly we can just mirror the points. The back side, we can again make the surface, and we have canopy on both sides. So now, so this is the backside where the planes are going to park. So with visibility graphics, I've removed those reference lines, splines, and this you can see this is ready. Now the main thing on this in this Trichy Airport roof are the panels which are placed on the roof. So we are going to make one module and adapt it over the complete roof. So first we are going to divide the surface. So we can quickly select horizontally and vertically what distance we should take and what shape we should take for the divisions. And quickly we can just divide. So we can, on the left side, you can see we can have fixed numbers, or we can have the size. So we can have different patterns also in this. So I've changed the pattern. So we can have some more patterns, honeycomb. cross patterns. In the canopy also we can have a different pattern because it's a different surface. So now we have divided the roof. So now we have to make one module and adapt it on the roof so that it runs all over the roof. So now we have to make that element. So for element, we'll take another family, and we'll just make one module and adapt it all over the roof. So now then the roofing structure will look similar to the Trichy airport. So first we decide the shape, taking the same point elements. We can have multiple elements. So this is one module. So this module is partially open also. So we can, decide we can make one parameter which will decide the opening of the panel so that the light can come in through those panels. So you can see the material we have changed to glass. We can select the material, then just quickly move forward. And now how to open the panel. So we are making one more parameter, height. So now this will move according to, whatever height we select. So you can see here that the opening is there, and now we can select the material. So now we can change the opening here from the formula. So height we can change 500. So it can be closed or open. Now we have to put it on the roof. So now this is the roof, and we have to put that panel. So we are going to import it as a family. Oh, sorry, this is 1 second. So yeah. So we'll just save the roof panel. We are going to just import it. We'll just select the roof panel. It's a new family that has come in, and you can see now it will just adapt over the roof. So it's just loading, and you will just see this. Yeah, now you can see the change here. Now those small form modules have come up and adapted on the roof. So now we have the roof like we have on Trichy airport. So here it's the complete roof. Now you can see that it is adapted on the roofing structure, and we have the proper roofs. You can see by zooming in. So we can also stimulate the openings of different modules by the sun movement, like you saw in the Al Bahar Tower. Obviously, I have not, because of the time constraint, I have not added the Dynamo script. So we can control the panels by the sun movement and using Dynamo. and when the sun moves, the panels can also move. So that will further, make it more sustainable. Okay, so that was about modeling the complex roofs. So just wanted to show you that it is very much possible in Revit and easily doable. So I guess all the questions were already answered by all our panelists.
But we can still take, maybe just take some question. Anyone would like to elaborate further?
Yes, please feel free to just unmute, and if you would like to answer the question.
I'm sorry, did I miss anything, Farhad?
Maybe Farhad, you can ask some question which were like asked. So, Anand, there was one question for you, like how was fireproofing in the steel structure achieved?
So I have answered all the questions, but for the sake of doing it again, we had steel in two different forms. There was steel which was part of the composite steel structure in columns where there was concrete cladding. And wherever it was exposed and only under a false ceiling, we did intumescent paints. Intumescent paint structure.
I think there's another very critical, important question, and I'll open this to all the panelists. Anyone can take it. Like how sustainability be integrated in BIM? So, Anand, you like to take your take on that?
Sustainability is a frame of mind. It is something that gets woven into the way design is done, right? And it's as in DFI, we have made sustainability a part of the way we approach design, both at the passive sustainability level and at the active sustainability level. At the passive level, it is the architectural interventions through which we bring sustainability into our projects. Active via the use of the right material, via the use of right technology, the frame, the envelope, the MEP, the air conditioning, etc. So for active, we have enough data available, but for passive, it is more often than not the mindset of the architect which comes into play.
So I would like to add to the sustainability part that wherein we look at hello
Yes, yes, we
yeah
can hear you.
Please
wherein we
continue.
look at sustainability is in terms of savings of material and definitely ease in bringing the easiness to production erection etc, wherein you save a huge amount of time frame. So when it comes to both of these aspects, when you are using BIM as a platform, mainly for all our precast projects and this GFRC cladding also what we did in airport, so the wastage becomes very very minimal. In some of the factories like Katera or KEF Infra, you might be known. So we extract the even the rebar bar bending schedule in machine learning format. Now Revit also gives a PXML format. So this PXML format was then dumped into these automatic rebar cutting and bending machines, wherein the wastage was also very very minimal. So there was a savings in terms of material also, and that also could be added as a small part to the sustainability overall as a concept.
Yeah. And just to add, like Anand gave a design perspective to sustainability, be to on during the construction and similarly during the operation. So all the digital twin has been nowadays used to ensure that how are we able to further optimize at various things in sustainability during the operation and maintenance. So it is helping at all the different stages. So that's what I like. So anyone else would like to, I'll open to Anand and Sabir if they like to take any question and elaborate more, because verbally probably we can add more than what we have typed in. Okay, there has been a question of modeling trusses in Revit. Have you automated it or normal modeling is done? Anyone would like to take on that?
Let a structural engineer take that.
Okay. Shabir, you like to
So
answer?
actually, there are several platforms available. So one parametric modeling project which we are doing, wherein you can integrate or you can do using Rhino, Grasshopper, and then take it to the Revit platform, or using Dynamo also you can automate that. So these are one of the two platforms which you can use to do that exercise.
Yeah. There have been a lot of questions, but in interest of time, I'll maybe last one or two questions. Anyone would like to add on? Anand or Sabir, or your general experience around BIM or doing this complex structure?
So overall, BIM has been a good experience, but when it comes to the overall project, so we have found limitations. Like if one of the agencies are using BIM, it might not help to a drastic, extent to the entire overall project. But then that particular discipline, you are definitely able to streamline. For instance, in all our precast projects, we are mandatorily using BIM. Whether the architect or MEP consultant or services consultant uses the BIM or not, we use BIM on all our precast projects. The reason being, we have to deliver accurately the production drawings, erection drawings. So by default, we are using. So what I see is still there are certain limitations due to the entire ecosystem which needs to evolve around the BIM. And BIM, I would say it's only a process. So don't misconsider it like a software. So it's a process wherein you can use any software which eventually reduces your amount of time, adds value to your process, enhances the digitization of the construction segment, etc.
Anand was also saying something. Anand, you want to add something?
All I can say is that um, the complexity of the design that we attempted in Guwahati Airport was possible only because we had a powerful tool like Revit available to us. Of course, it helped us put into shape what the design aspirations are, the quantity takeoffs, etc. Of course, all that happened. As for quantity estimation, it did really work, but for time scheduling, etc., it could not be taken to its logical requirement and to its logical conclusion because contractors were not in sync with the overall BIM platform. But at design stage, we really benefit.
Just to add to what Shabir and Anand said, many of our clients' expectation is okay. Today I buy the software, and from tomorrow I'll be able to turn around completely BIM-able process-driven projects. I just want to put a word of caution there, like what Shabir very clearly mentioned. It's a process, and any process, the biggest challenge is team understanding and executing as per that process. It's a journey which will take some time within any office. Don't expect just buying the software and getting some training done. You'll be able to deliver it completely. And you'll have to, and like what's another important point which Shabir mentioned is the ecosystem. So it's obviously in any new project, your entire ecosystem will not be on board. And you'll have to kind of deal with such situations. And it'll take some time. Don't in 3 months, 6 months, year, or something like that for you to actually move your entire practice to a BIM enabled process or leveraging complete end to end. So don't expect miracles just by buying software and training. It does take time. And as you use it more, and like in many countries, they have put it as BIM level, maturity level. So think about like you start maturing, as you start using it more and more, you'll mature and be able to do a lot more work and be able to do a lot more value add to your current practice. That's how I like to mention. Back to
Yes, I
Farad.
think you
Yes.
have very rightly said this point because this is really a mindset of a lot of people. So even during a lot of our precast events, I've highlighted the way we have been using BIM is almost like since our inception, 2014. That's the reason we have been able to reach where we are today. It's not a days game or months game. It's a process wherein you need to create your entire company's ecosystem also around that platform.
Farhad, back to you.
Thank you, sir. So, again, I would like to thank you, everyone. Thank you, our panelists and the attendees, to be so patient. And if you have any further questions, obviously you can contact me or contact our marketing team at connect@capricorn.com. So if you would be happy to answer other questions. So thank you everyone for joining and have a nice day.
Bye bye. Thank you. Thank you. Thank you, Anand. Thank you, Shabir.